Let's talk about cancer. It's the second leading cause of death in the US, and one of the scariest diagnoses a person can receive. But not all cancers are equal. Do you know which cancer is the deadliest? It may surprise you to learn that lung cancer deaths surpass the next three top cancers combined. The chart in the upper left corner shows the number of US cancer deaths in 2020, and you can see how devastating lung cancer is. How is this possible? Well, lung cancer has a problem. And that problem is lack of understanding. For one thing, many people think lung cancer is simply caused by smoking, and the only tool in the fight against lung cancer is to get people to quit. While smoking can be a major factor, it's not the whole story. According to the American Cancer Society, 20% of those lost to lung cancer never smoked a single cigarette. This means other environmental agents are a problem. One such agent is chromium. Chromium is an air pollution caused by metalworking, waste incineration, cooling towers, and more. We know chromium causes lung cancer, but we don't yet understand how. And that's where my research comes in. I'm working to understand how. Before I go on, let me teach you a word: chromosome. A chromosome is where the DNA is packaged and stored. You've already heard of chromosomes because you know about X and Y chromosomes, and how women have two X chromosomes, and men have an X and a Y. Well, each human lung cell contains 46 chromosomes, but lung cancers contain many more. I'm looking inside cells to find out how chromium can change the number of chromosomes in a cell, and I'm very interested in a particular pair of actors, securin and separase. As seen in the upper right corner, separase acts like a chainsaw, ripping apart chromosomes and the anchors that organize them. Securin, on the other hand, acts as the safety lock for separase. My data show chromium turns off the securin safety lock in human lung cells, allowing separase to run wild. A chainsaw on the loose is never a good thing. In the bottom panel, we see that normal dividing cells have two anchors, and they evenly organize the chromosomes. However, after chromium, separase cuts apart the anchors, and now there are 4 anchors. This disruption causes cells to end up with too many chromosomes. My work will reveal how chromium turns off the securin safety lock. I'm studying what chromium does at a microscopic level to learn the key steps of this effect, and I'll also study these effects in live lungs, and I'm looking inside lung tumors from people who died of lung cancer caused by chromium. The answers I find will provide key insights into how metals cause cancer and sharpen an essential tool in the fight against lung cancer.